Hi, my name's Daniel, and I'm going to explain an idea that we have. So, you run a website. It has loads of content, which means loads of links. You know that you have broken links, and possibly other not so great HTML. But where are those broken links? How many of your users try to do something important, only to be presented with a 404 error? This is SSW Link Auditor. It's a desktop application that can help you scan your websites for broken links. Here's a quick overview of the product as it is now. It has loads of features. It'll check for anchors, images, good HTML, CSS and JavaScript practices, support scanning pages secured using HTTP and forms-based authentication methods. It can check for case sensitivity and even tell you how your web pages are doing in Google's index. Before you can start scanning though, you'll need to install some reporting components, configure a local SQL database instance, and then have Link Auditor create its database. There we go. Once the database is configured, you can specify which rules you want to check for. SSW is more than just a link scanner. Included are rules that check for many common HTML, CSS and JavaScript best practices that can help with compatibility and the performance of your web pages. Scanning and processing then runs locally, and when it's done, you get a nice report of everything that it discovered. SSW Link Auditor does have loads of features. It supports scanning pages that use authentication, is highly configurable, and even uses client processing power. But it is a desktop application that is time-consuming to set up, including dependencies and reporting components and a local database. So with that, we'd like to make some changes. We want to pick up the SSW Link Auditor scanning engine and move it to the Azure cloud to run as a worker role. In the cloud, users must be able to submit scanning jobs to a queue, which will then be processed by the Azure worker. To go along with the new service, we'll also need a shiny new web-based UI. Moving it to the cloud will make it a lot quicker to get started scanning your web pages and opens up interesting opportunities to gather statistics on a range of websites. Let's take a look at an example that will show what we want for a minimum viable product. Meet Frank. He's a website admin. Frank is concerned that some of his customers haven't been able to place orders on his website. Frank navigates to www.sswlinkauditor.com where he can schedule a scan of his website. After logging in, Frank navigates to the Create Job page. Here he can enter the initial URL he wants to scan, as well as some other basic scanning options that are available in the desktop version of Link Auditor. He then clicks Add to queue the job for processing. In the backend, Frank's job is added to an Azure message queue. With the job in the queue, once its turn comes up, a Link Auditor worker role grabs it and starts processing it. Frank can then view the status of his job in the job list page. Here he can change the priority of queued jobs to make sure the important ones run first. When a job completes, its status changes to complete and its report becomes available. The report shows a summary of the scan, from which Frank can drill down into the specific issues that were found. This report includes broken links, as well as any HTML, CSS or JavaScript warnings and errors. So how do we want it built? There are two main parts to this project, which can be tackled by two teams. The front-end web user interface and the back-end worker role, which will also need some admin web interface components. First is the front end, a new web interface for users to sign up, create scanning jobs, view reports, and eventually purchase additional scanning features. We want it built on ASP.NET MVC with the AngularJS client-side framework, Bootstrap to simplify UI, SignalR for real-time client updates such as on the Running Jobs page, and Kendo UI. Second is the backend. This includes migrating the Link Auditor engine from the desktop product to an Azure worker role, as well as some of the related administrative components in the web interface. We want the backend to be hosted on Windows and SQL Azure, using Structure Map for dependency injection and Log4net for logging. In the future, we would also like to migrate the project to Visual Studio Online, at which time we'll take advantage of application insights to help monitor the performance of Link Auditor in the cloud. So that's it for the MVP. We have a lot of other items in our backlog though, and now I'll go through a few that would be really great to have to put the icing on the cake. A quota and payment system, so that the free version is restricted to scanning links for a single page, then users must pay to automatically scan deeper links. After all, Azure CPU cycles aren't free. The ability to let users change the priority of queued jobs. Application insights when the project is migrated to Visual Studio Online. The ability to scan pages that are protected with authentication, like in the desktop version. Advanced statistics. We want to publicly show interesting aggregated statistics from scans. For example, what percentage of scan sites are using SharePoint? Or what percentage have more than 30% JavaScript? An advanced dashboard with the ability to tweak job parameters in real time. And custom rules, allowing the scanner to report on custom HTML patterns. For more details about these features, you can have a look at the product backlog at r.ssw.com/linkauditor-backlog. Pretty simple, don't you think? Thanks for watching.